Hello students, how are you? I think all of you are fine at home. Now I am going to start my class. My chapter is aldehyde and ketone. First of all, we discuss the classification of aldehyde and ketone. So before classification, you should know aldehyde functional group. This is aldehyde functional group. Aldehyde functional group. And this is ketone functional group. Ketone functional group. Functional group. Ketone functional group. And they are simultaneously known as simultaneously they are known as carbonyl functional group. Carbonyl functional group. Functional group. Simultaneously they are known as carbonyl functional group. Now classification. Classification. Classification aliphatic carbonyl compound, aliphatic carbonyl compound and aromatic carbonyl compound. Aromatic carbonyl compounds. So this is aldehyde functional group and this is ketone functional group. If there are H or R, and R or R dash, then it is aliphatic. But R must be alkyl radical. Alkyl radical such as methyl, ethyl, etc. So with aldehyde functional group, if there are either H or R, then it is aliphatic compounds. R must be alkyl radical. And in case of ketone, you see that RCO R dash. So in case of first one, R are same, and in case of second one, R dash different. If R are same, then it is symmetrical ketone. R and R dash are different, then it is unsymmetrical ketone. So what is aliphatic carbonyl compound? It is clear to us. Now we move to aromatic carbonyl compound. Aromatic carbonyl compound means there must be benzene ring. There must be benzene ring. That is aryl radical aryl radical. Aryl means bond C6H5. Aryl means bond C6H5. So compound CHO, its name is benzaldehyde. Benzaldehyde. And another example, COCH3, it is acetophenone. Acetophenone. Both compounds are aromatic carbonyl compound. So it is clear to us what is aliphatic carbonyl compound and what is aromatic carbonyl compound. Now, general formula. General formula of the carbonyl compound. General formula of the carbonyl compound. In case of aldehyde, CN H twice N plus 1 CHO. It may be written as O. So general formula of aldehyde compound is CN H twice N plus 1 CHO, or it may be written as CN H twice N O, where N equal to number of carbon atom. N equal to number of carbon atom. And for ketone, general formula is CN H twice N O. So for ketone, CN H twice N O. So question may arise, general formula of aldehyde and ketone both are same. Yes, general formula of aldehyde and ketone both are same because they are functional isomer to each other. General formula of aldehyde and ketone both are same. Because they are functional isomer to each other. They are functional isomer to each other. So next topic is UPAC nomenclature. UPAC nomenclature. Everybody you know that every functional group has prefix and suffix. So in case of aldehyde, its prefix is aldo, or to some extent formyl. Both are correct. Aldo or formyl. And suffix is al. So question is arise, what is prefix and what is suffix? I am giving you two examples, such as CH3CHO and CH3CHO. CH, CHO, COOH. You see that there are only one functional group and there are two functional groups, carboxylic acid and aldehyde functional group. So, in case of only one functional group, it is the main functional group. It is the main functional group or primary functional group, or primary, any one is correct. Primary. And in case of different functional group, one is primary and another is secondary. So priority order of carboxylic group, it is main and it is secondary. It is secondary. Main, that is primary. Primary. Because priority order is carboxylic acid greater than aldehyde functional group. So, in case of main functional group, we have to use suffix, and in case of secondary functional group, then we have to use prefix, such as, see that. And in another rules is, in case of carbon containing functional group, you have to start at numbering from that carbon which belongs to functional group. So aldehyde belongs to carbon, so its number is 1 and it is 2. So its name is ethanol. Ethanol. L, suffix L, ethanol. And in that case, you see that it is secondary and it is primary. So, in case of carboxylic acid, its suffix is oic acid. Its suffix is oic acid. So, numbering 1, 2, 3. So, its name is 2-aldo. 2-aldo propanoic acid. Propanoic acid. 2-aldo propanoic acid. So it is clear to us what is prefix and what is suffix. Now, nomenclature. If single aldehyde group is there, then the style is alkanal. If two aldehyde groups are there, two aldehyde groups are there, then it will be alkane. Alkane dial. And if three or more than three aldehyde group are directly linked with the longest chain, then special suffix carbaldehyde, I mean box, it is in box, carbaldehyde, it is in box. then special suffix carbaldehyde is to be used. Now, first one, this is and this is. The first rules, alkanal, only one functional aldehyde group, only one aldehyde group. So alkanal, here alkanal is methanal, here alkanal is 1, 2, 3, 2-methyl propanal, NaL, 2-methyl propanal. Then we move in the second rule. See that aldehyde OH CHO. So there are two aldehyde group directly linked with longest chain, 1, 2 and 3. So its name is 2-hydroxy propane. You see that the difference between the spelling as well as pronunciation. Here propane and it is propanal and it is propane. 1,3-dial. Propane 1,3-dial. And the third rules, CHO, CH2, CH, CHO, CH2, CHO. You see that there are three aldehyde group. Those are directly linked with the longest chain. Then a problem is arise. What is the problem? If we start the numbering from this side, 1, 2, 3, 4, 5, then it is not in longest chain. And if we start from this side, 1, 2, 3, 4, then it is not in longest chain. So to overcome this problem, none of them are in longest chain. And numbering started from here, 1, 2, 3. There are 3 or more than 3 aldehyde functional group directly linked with longest chain. Then special suffix carbaldehyde is to be used. So you see that there are 3 functional group, aldehyde functional group directly linked with longest chain. Then all the functional groups are not considered in longest chain, and the numbering started 1, 2 and 3. So its name is propane. 1, 2, 3. Propane 1, 2, 3 tricarbaldehyde. Special suffix tricarbaldehyde. Now ketone. Now we will see the functional group of ketone. It's oxo/keto or keto. Nowadays oxo is used. Oxo or keto, and it is on. Suffix is on. Prefix and suffix on. And naming will be done by alkan plus one, alkan plus one, such as CH3, CO, CH2, CH2, CH3. So we have to see that from where we started the numbering. We have to start the numbering from this side. 1, 2, 3, 4, 5. Because ketone group occupy the lowest position. 2 position. Ketone group occupy the lowest position. So its name will be pentane. Pentane. 1, 2, 3, 4. Alkan. Pentane. 2 one. Pentane 2 one. If more than one is there, CH3, CO, CH2, CO, CH3, then you can start from any side. You can start from any side. That is, and name will be pentane. Pentane 2, 4 dione. Pentane 2, 4 dione. So spelling and pronunciation we have to remember seriously. So pentane 2 one, pentane 2, 4 dione. Now we will see the isomerism. Isomerism. So already you heard in class 11 tautomerism. So aldehyde and ketone, both the compounds show the special type of isomerism, that is tautomerism. Now we see what is the first and foremost requirement for tautomerism. We have to remember that for tautomerism, there must be alpha hydrogen 8 sp3 hybridized alpha carbon atom. There must be alpha hydrogen at sp3 hybridized alpha carbon atom. Such as, if we draw the two compounds, structure of two compound, it is benzaldehyde and it is acetaldehyde. In benzaldehyde, it is alpha carbon atom and there is no alpha hydrogen, as well as carbon is sp2 hybridized. So benzaldehyde is not responsible, but does not show the tautomerism, cannot form tautomer. Whereas in case of acetaldehyde, you see that it is alpha carbon and the compound is sp3 hybridized. I think everybody you know that the state of hybridization. So carbon is sp3 hybridized. So it can show tautomerism. Tautomerism. Acetaldehyde can show tautomerism. Tautomerism actually rearrangement of atom rearrangement of atom. Tautomerism actually rearrangement of atom. See that in acetaldehyde, this carbon is sp3 hybridized and at sp3 hybridized alpha hydrogen is there, and alpha hydrogen is acidic. Generally alpha hydrogen is acidic. So rearrangement of atoms, pi bond will shifted towards oxygen because oxygen is much more electronegative. As a result, carbon attain positive charge, and this hydrogen give up its electron. This hydrogen give up its electron. You see that after giving up, there were single bond. Now it become double bond, and C, oxygen attain negative charge due to shifting of pi bond, and hydrogen attain positive charge due to give up its electron. Due to give up its electron, hydrogen attain positive charge and oxygen attain negative charge. So OH and H. This form is ketone form, not ketone compound, ketone form, and this is enol form. Why enol? Double bonded carbon is in and OH, so it is enol form. So keto enol, this type of tautomerism is known as keto enol tautomerism. And another important note, you have to remember that all the tautomers, that is keto form and enol form, tautomers are dynamic in equilibrium. You have to remember that dynamic in equilibrium. Tautomers are dynamic in equilibrium, and generally among keto enol tautomerism, among keto and enol tautomerism, keto form, generally keto form is more stable. Again and again, I am telling you that generally keto form is more stable. Keto form is more stable, but to some extent enol form may also be stable. To some extent enol form may also be stable. By how? By gaining aromaticity, such as this is enol form, this is enol form, and its keto form will be double bond O, H, H, A, keto form. Hydrogen give up its electron, and this pi bond will be shifted to this carbon. As a result, we get this structure. It is keto form, and it is enol form. Among this, enol form is stable. Enol form is stable. Enol form is stable. I think everybody clear that what is tautomerism and keto enol tautomerism, and any question then you asked me in the next class.